been working at UNH-IOL for a while now. I think I've worked with many of the folks in this room. I have no idea how many plug fests I've been to or organized. But to help me in this presentation, I'd just like to get a little bit of feedback from the room. You know, when I think about NVMe, there's a lot of folks that have kind of heads down on the SSD side, SSD controllers, paying a lot of attention to kind of that side of things. And now we've seen so many people come in for NVMe over fabrics coming from the storage networking world. So I'd just like to get kind of a show of hands for who's kind of more on the SSD side of things, who's a little bit more on the fabric side of things. So SSD folks, okay, and fabrics folks, storage networking folks, okay, all right. Who knows both? Plays in, okay, wow, all right, good. So we've got a nice informed audience here. A lot of what I'm going to talk about today, I'm going to give you a little bit of background on where we've come in terms of SSD testing at the PlugFest and the Interop that we do on behalf of NVMe.org. And then I'm going to get into some things that we've been trying at recent NVMeoF PlugFests and some things that we have planned for our upcoming NVMeoF PlugFest. So a little bit of a current state of where we are with the integrators list, and then looking at some interop testing that goes a little bit beyond what's defined in the NVMe specification. So it's not really part of compliance. It's not really part of the integrators list testing that we do. But if you want to have a successful deployment, there's interop issues that you really need to be looking at and address. So I'm going to talk about those. So first, a little bit about the test specifications. Today, there's 5 test specifications that we've put together for NVMe. There's NVMe Interop, NVMe MI conformance, NVMe conformance, NVMeoF Interop, and NVMeoF conformance. And where do those things really apply? Well, for hosts, or for SSDs, really those first 3 apply. So if you've got an SSD, if you've got a server that's going to have an NVMe SSD in it, the ones you want to pay attention to are those first 3. NVMe Interop, NVMe conformance, and then if you're supporting NVMe MI, NVMe MI conformance. If you have an NVMeoF product, obviously you care about NVMeoF Interop, obviously you care about NVMeoF conformance, you also care about NVMe conformance. Because remember, we've been talking about how some features from the NVMe specification, that base specification, apply to SSDs, but they all apply to, also apply to NVM subsystems that might be attached via a fabric. So that's a little bit about how the test specifications themselves break down and what products they apply to. These are the things that the ICC is reviewing and creating TPs for and modifying with each new release of the NVMe specification. So that's what's on paper. Of course, in the future, we're going to be looking at adding testing for the NVMeoF binding specifications. All those things are posted up on the UNH-IOL site. You can go and look at them. Then there's the test tools. And similarly, if you're working on an SSD product that's connected over PCIe, you might care about different tools than if you're working with a fabrics product. So for the SSDs, we have the NVMe Interop. We test with some open source software. A lot of times we use VDBench for just generating I/O on Interop. We also use the Quark tool, if you're familiar with it, for doing some hot plug tests that'll test SSD hot plug. And then for MI conformance and NVMe conformance, we've got some tests implemented on the Teledyne LaCroix tool, and then some tests available on our own Interact software. Now on the fabric side, again, we use some free, just simple open source I/O generating tools. But then also, we test those same NVMe conformance tests, that base specification test that applies to fabrics. We do that with the Interact software as well. And then in the future, of course, we're looking at adding the testing for the binding specs. Now, this morning, we talked a little bit about the NVMe tests, how some are FYI and some are mandatory. Right now, there's almost 250 tests that are defined for NVMe compliance. Of those, 80 are FYI. Now, why do we have FYI tests? Those are tests that we put out there. Oftentimes, they're based on new features that have been put in the NVMe specification. We put out there for people to run them. We make them available in the tools, but we don't make them as hard requirements yet for being on the integrators list. And the reason for that is we want to validate those tests, we want to vet those tests, and we want to give people a lot of notice about things that might become mandatory in the future. So that's what you see, that big section there about FYI tests. Every time we rev the test program, some of those FYI tests become mandatory, But then we also add some more FWYI tests according to what new features have been introduced in the specification. So you'll see that kind of wedge of FWYI tests. It might change a little bit, but it's always going to be there because we're always going to be adding new tests for new features that get added to the specification. Now, originally, when we first started doing this testing, we were laser focused on testing SSDs. We were laser focused on testing over the PCIe interface. Obviously, that's changed. We're testing now over Rocky, we're testing over Fibre channel, we're testing over TCP. A big chunk of those tests, of those 248 tests, apply both to PCIe drives and also to NVMeoF NVM subsystems. So that's that darker section of the circle there. Those are tests that apply whether you're making an SSD or whether you're making an NVMe over Fabrics product. And then a little less than a third, or a little more than a third there, 97 tests apply just to SSDs. They're specific to PCIe. Now, zooming in on those ones that apply to NVM over Fabrics test, of those, again, you see roughly a third of them are mandatory. This is something that we're going to work on trying pushing the other way to get a larger section of those made mandatory and then have smaller ones, smaller section be FYI. Part of the reason you see that difference here is simply that these tests are newer. And so we want to make sure that we fully validate them, fully vet them, run them through a plug fest to make sure that we're not springing any surprises on anyone. So you see my note here, we're going to have our next plug fest in June of 2019. At that time, all these tests are going to be reviewed, all those FYI tests are going to be reviewed, and we'll make a determination about whether they can be introduced as mandatory or not. So a little bit about our process. This past fall, we added 9 test cases that were specific to NVMeoF protocol. Those are transport agnostic. So it doesn't matter what fabric transport you're using, whether it's Rocky, Fibre channel, or TCP, those tests apply because they're drawn from the NVMeoF specification. Some of the things that those tests look at, you see there in the second box, connecting to an NVM subsystem when it's remote, using the property get command, checking the identify command, testing the functionality of the discovery controller. So those are all things that we added. You can go see the test document there in that hyperlink. Again, we're going to have more requirements added after the June plug fest. Some of those ones that were FYI will be made mandatory. And in the future, the cycle repeats. So we'll be looking at new features to add to the program. One that we're really focusing on is testing for the binding specifications that we don't have testing for today. Now, when we very first started testing SSDs, we very deliberately focused on testing NVMe protocol. And we deliberately did our best to kind of ignore testing PCIe. Why? Well, because PCI SIG does that, and they've done a good job of it for a very long time. So if people want to have PCIe validation done, that's what the PCI SIG and their integrators list exists for. So we certainly don't want to be in conflict with that or do redundant work with that. So we encourage people to test with that for PCIe validation, and then work with our program for the NVMe protocol validation. And PCI SIG, as we know, is very well organized and does a good job with that. But when you start to look at the fabric side and the transports there, is there some kind of analog on the fabric side as there is for PCIe? And the answer is, well, it depends. And maybe there's some things that we can do there. So when we look at what happens at the NVMeoF Plug Fest that we run at UNH, lots of people come and test on fabrics. Lots of people are very interested in putting products on the integrators list. We've seen a lot of traction on Rocky testing, a lot of products coming through with Rocky interfaces. And when we did our proof of concept test for NVMe over TCP last fall, it was very encouraging to see the number of vendors that were participating in that and how many went. But if we want to have successful deployments of these technologies, there is a need to do some checking of the underlying transport. But that's a little bit beyond the scope of what we want to test as part of an NVMe Integrators List program. As part of the NVMe Integrators List program, we want to check NVMe protocol. That's what we want to focus on. But there are these things, these parts underneath that we want to, that if we want to be successful, have successful deployments, we want to check those as well. And so when we do these plug fests, we've got everybody in the same room. We have the ability to do some really interesting interop tests with that. And so I'm going to share with you some of the things that we've been doing at those events, and then some ideas that we have to do at future events. And so kind of the way this is broken down is that the first couple days of our PlugFest, we focus on doing the integrators list test. We focus on doing the NVMe conformance test and the NVMeoF conformance tests and all of the interop tests that are required for putting a product on those integrators lists. Then the next 2 days, we do something that's a little bit more informal, something that's informative for the people that are attending, and something that has proven to really uncover some really interesting corner cases with those underlying transports. Now, we want to remember that each one of those underlying transports kind of has its own idiosyncrasies, kind of has its own needs. We want to make sure that we put this together and we offer something to people as part of that event that is going to help them find interop issues, help them find bugs that are important to solve before they actually deploy NVMe. And remember that this is something that is separate from the testing that's happening as part of the NVMe integrators list. So I'm going to talk a little bit about what's been done on the fiber channel space, what's been done for Rocky, and then what some ideas we have for testing TCP in the future. So we know, I'm sure a lot of you have heard of the work that's happened at the Fiber Channel PlugFest. They've been doing Fiber Channel PlugFest since I was a teenager. I was actually attended my first one as a teenager. And and you can read into that whatever you want. Yes, thank you. I remember seeing you there, yeah. So for a long time, those FCIA PlugFests, they had a feature of it that was the large build, right? So they would do some very prescribed tests kind of the first half of the week and then do a large build. And when they did that large build, it really uncovered some very interesting corner cases. And so it's something that I think these other tests, specifically that we're doing for Rocky and TCP, we can kind of learn a little bit from that and try and take that kind of large build approach and use it there as well. So some things that we did in the past at Fiber Channel events, running FC protocols in parallel. That was a very interesting one, running FCP and running FCNVMe in parallel on a network, because that was a very important use case for Fiber Channel. People are very interested in seeing that happening. So that was one thing that's been done at PlugFest. Other things we did, check for error recovery in Fiber Channel. So we actually had good participation from the test equipment companies and used the jammer for booting buffer-to-buffer credit. That's a very interesting error case. And some of that actually got fed back so that that could be something that was covered and fixed, or not necessarily fixed, but added to the specification. So those were some interesting test cases that came out of that large build that were really useful for the community and really useful for the folks that were participating. And like I said, Fiber Channel is very well organized to do that and has been doing it for quite some time. Now, if you move to the Rocky side of things, you don't see the same type of organization as you do on the Fiber Channel side. So some things that we've done for Rocky, simply verifying that you can connect and discover to a target over the network. Verify that I/O is working, run that for many hours, run that for overnight or for multiple days. We found some very interesting test cases where we inject congestion or cause congestion in the network. There's lots of different ways to do that. Monitor for whether or not pause frames are used when you do inject congestion. So these are some of those corner cases that don't come up if you're just verifying NVMe compliance. They don't come up if you're just verifying NVMeoF compliance. It happens when you actually do kind of a large interop build. So there's a lot of other things that we can do in Rocky around data center bridging and QoS testing when in a congested environment. So what do those things kind of look like? Well, again, we basically made a large build. This is a diagram from our previous PlugFest, actually previous two, we did a large build like this, where we have a number of RNICs and a number of Rocky targets or NVMeoF NVM subsystems connected to the network, and then we add congestion. And you can do that with a test tool that'll add congestion. You can kind of play with the size of the pipes that your hosts are connected to the switch and versus your targets are connected to the switch, and you can see how those products behave in that environment. Because when we're doing the conformance test, we're not adding any kind of stress there. We're not adding any kind of congestion. We're not trying to see how these products are going to perform in a congested environment. We're just trying to see, are they conformant to the protocol? And so we do it in a congestion-free environment, a very clean environment. But in the large build, that's your chance to actually see some of this stuff in action. So That was one test case. Another test case was simply, how do things heal when we start breaking links? So if we break an interswitch link, if we disconnect a target, can it be discovered again? If we disconnect a host, can it be discovered again? So that was another set of interop tests that really kind of uncovered some interesting corner cases. Those are all things for Fibre channel and for Rocky. Those are things that we've done in the past. We'll probably do them again in the future or some kind of minor modification of them. This next PlugFest in June is going to be, we're going to be having NVMe over TCP testing. And so what kind of things can we do there? And so I'm going to share some ideas for some things that we can try and do at that event. I'd be very interested to hear other ideas about things we can do as part of that informal large build that would be, again, unveil interesting corner cases about NVM over TCP. So a couple things we were looking at, do some one-to-many tests or many-to-one, and then also cause retransmission events, and then perhaps in the future, checking discovery when TLS is enabled. So what might that look like? Well, causing retransmission, similar approach to what we did in some of those Fibre channel tests, jam ACKs. So, and cause that retransmission to occur, look at what happens with back-off timers, see how that affects performance. So this is something that we'd like to try at our PlugFest in June, again, after we do all of the conformance testing. Another possibility, distributed reads, so a single host writing to many targets and then reading back from many targets and looking at the possible congestion issues that covers. And then also the opposite, a single target and many hosts writing to that single target. So it's essentially a shared pool of storage that's shared among many hosts. So those are a couple ideas that we had for some informal interoperability testing that we could do that could really benefit the community, again, outside the scope of the integrators list testing. So some next steps. We're going to be doing a webinar to help people prepare for that PlugFest. We're going to do that on May 7th. The registration is open now. And the purpose of that is to really help people prepare themselves for attending the NVMe PlugFest. For folks that have come to those PlugFests before and tested on the SSD side, it's a very well prescribed event. We'll have all the interop systems there, and we'll focus on doing that conformance and interop testing. For the folks that are going to be coming for the Fabric stuff, after this webinar, we're going to do a series of planning calls to help us prepare for doing those various large builds. And so that's going to be the opportunity for us to kind of collect some feedback, make sure we have all the right equipment for doing those large build tests. The registrations for the PlugFests are there. You can go and see that. So in summary, lots of people are using the integrators list. That's a real mark of success for the program and for this community. All of that testing and all the definition for that testing, it's gone through a nice and rigorous ratification process within NVMe.org. All those docs are up there now on the site. You can go and look at what that testing is. We're hoping to add testing beyond just NVMe and NVMeoF in the future and do also testing for the binding specs. And the test tools, of course, already support those things. But when we've got everybody in the same room at those PlugFests, we want to take advantage of that and kind of continue that tradition of doing a large build with those different transports. And so I've proposed a couple ideas for some things that we're going to try. I'd be interested to hear here or offline about other ideas that would be really useful to do in that large build testing. We want to make sure we take advantage of that. So with that, are there questions about that? Or yes, please.
Sorry. So those jammer test cases that you have put up, is there any guidelines of how deep you want to go in terms of interoperability? You can do a lot of jammer cases, right? So what is the guidelines that you use to decide, what is the level of jamming that you want to do?
Sure. Obviously, we're restricted in time, right? So we have, a day or two that you can actually dig into that. And we also want to make sure that everybody kind of gets a chance to have their stuff jammed, in a sense, right? Everybody needs to have that same opportunity. So part of that just falls to the planning calls. So in the past, when we've done it, we've just kind of done an informal poll of what kind of traffic would be the most important thing or the most interesting thing to jam or to throw away, right? So that's kind of how we chose that. You're right, there's a lot you could do there, but we are restricted with the number of hours that we have to do it. So if you have feedback on that, I would very much encourage you to attend some of those planning calls.
But that will be standardized and documented, saying this is the list of test cases that I will run?
We will document it so that everybody attending will know what we're planning on doing, but I want to emphasize that that's not something that's going to be part of the NVMe integrators list testing.
Okay.
Yeah.
Thank you.
Yeah.